All right, everybody, welcome back. Welcome back. Section 1.2, measuring and constructing statements. Actually, you know what? I should rename this one because we're not going to be constructing. Not today. We're going to do that in class because we're flipping it around. You're doing the work at home, helping yourself out. And if you're watching this, you're doing a great job. You're taking your own education into your hands. As you can see, we're talking about segments today. And appropriately, I've put a segment down here at the bottom. Think to yourself, what are some of the characteristics of a segment that you could possibly remember? Why, yes, it does not keep going. It stops. And in fact, it has end points here. And because it's a segment, I'm going to put its endpoints as S and T, the end of the word, the ends of the word segment. Okay, so this is section 1.2. So get your brain thinking about segments right here. We're going to start out with a postulate. Now, I didn't explain this last video, but these postulates, which are statements that are accepted as fact without proof, are going to go like this. Chapter 1, section, and the number of the postulate from this section. Okay, so this is chapter 1, section 2. This is the first postulate. It's called the ruler postulate. We're going to be using rulers a lot in this class throughout the year. This is kind of an explanation of what it actually means to use a ruler. What does it mean to use a ruler? Well, we're measuring the length of something. Well, you'll see down below I have a segment here, AB, because we're talking about segments this section. The ruler postulate says this: the points on a line can be matched 1 to 1 with the real numbers. Think about that for a second. From algebra class, real numbers. The real number that corresponds to a point is the coordinate of that point. So I would say down here that the coordinate of A is 1. Okay? The coordinate of B is 8. Now some of you are sitting there thinking, well, I already know that it's 7 inches long or 7 centimeters or 7 miles, depending on what the scale is. So why am I learning this? Think about this for a second. You can obviously count that there are 7 inches between there, but what about if we started somewhere in the middle, or we were dealing with something exceptionally long? How do we deal with that and measure it? Well, the distance between point A and point B is written as AB. Notice, this is segment AB, or we call it AB with a segment across the top, yeah? But think about this for a minute. If I'm talking about the length of AB, the length of AB is actually going to be equal to this. The length of segment AB is just AB. I don't want to blow your mind. But think about it like this. If we put the segment over the top, we're talking about the actual picture of that item. So if I had the AB with the little segment over the top, that's talking about the actual picture of it itself. That's this part here. Okay? If I write AB, I'm saying AB is equal to something. And you're going to say 7 because you've noticed that the coordinates. Now, how do we figure that out? Well, let's look. It says it's written as AB, which we did. It's the absolute value of the difference between the coordinates of A and B. So absolute value, that's the big bars, right? So the coordinates of A and B. So let's see, A is at 1. So the difference between those two, 8. 1 minus 8 is the absolute value of -7, which is equal to 7. But what if we flip that around? Because remember, AB and BA are the exact same segment. So that would be the absolute value of 8 minus 1, which would be the absolute value of 7, which is 7. Do you see how that works? So it doesn't matter which one I put first. We would like to subtract the easy way and say the bigger one minus the smaller one, but we don't have to because it comes out the same. See how that works? It's a beautiful thing, that math. Okay? So that's postulate 1, 2, 1, the ruler postulate. Now, measuring. How do we measure things? let's look at this. We are going to be finding the length of a segment, and we've got E, and what I didn't show you was that this is actually a number line. And here's how we're going to go. -4, -3, -2, -1. C is going to be at 2. D is going to be here at, I'm going to try to confuse you here, 4.5. So see, on my number line, they don't necessarily have to always match up exactly, which is what it's going to be like in real life. This will be 0, 1, 2, 3, etc., etc. Okay, look at what we've got here. I'm measuring. So I'm going to find the length of the segments. Okay, so for those of you playing the at-home game, which you should be, we're going to take what we already know. Now, DC, how do I know what I'm finding here? Well, let's look. Remember, the length DC, when it doesn't have the line above it, is talking about the number value. So I can say DC is equal to some number. I don't know what it is yet, but I'm going to look, because I know that it's the absolute value of the coordinate of D minus the coordinate of C. 4.5 minus 2. So the length of DC is right here. But what about if I had done CD? Would it have ended up the same? 2 minus 4.5. Yes, it would have. It would have been the absolute value of a negative 2.5, so we would have had 2.5. EF, see if you can do it on your own. If you want to pause and see if you can test yourself and do it on your own, great. EF. I'm going to have EF is equal to, let's look at this. I'm going to have the absolute value of -4 minus, F is at -1. Taking the difference here, -4 minus a -1. So maybe you've seen this little method before. Subtracting a negative is the same as adding. So I'm going to go with two positives here. Here we go. -4 plus 1. -3. See how that works? And if I wanted to count, I could go 1, 2, 3. Okay? So that's what we're doing here. We're finding the length of segments using this ruler postulate, because even though this isn't a picture of a ruler, it's the same concept as a ruler. We're matching them up 1 to 1. So E would have the coordinate of -4, F would have the coordinate of -1, etc., etc. Okay? That's how this works. Now, something for you to do. If you didn't pause on that last one, I definitely want you to pause right here. I definitely want you to take some time. I'm going to fill in these values here, but go ahead and copy this example down. We're doing the exact same thing. Finding the lengths of the segments. There are a lot of people out there in math. They're like, "Oh, I'll just watch it, and I know what to do. I don't have to take notes. I've got a photographic memory." Well, I've got news for you. I thought I had a photographic memory once. I found out it was out of film. So make sure you are taking these notes down for viewing later. Okay? So here we go. Z is at -3. We're going to go this way. X, going to try to confuse you here. 1 and 1/2. And Y is going to be at 5. Okay? I'm not going to put in the in-between points. I don't want you counting. I want you using the ruler postulate and using absolute values. Oops, I gave you a hint. So go ahead and pause right here. See if you can fill in those values. And I'll be back with you in just 1 second. Okay, I'm back. Hopefully you paused and you did the problems on your own. But if you didn't, that's okay. Okay? If you need that support and you need that help, that's fine. That's okay. That's the beauty of the system. You can watch it, rewind it, redo it, relive it, replay it, whatever you need to do. Here we go. X, Y. The difference Absolute value of the difference between 5 minus 1 and 1/2. Let's see what we've got here. How are we going to get there? Well, we're going to say 5 minus 1 is 4, and then minus an extra half would be 3.5. So xy is 3.5. If you did it the other way around, it would have worked out. Let's do xz here. So we're going to have this is equal to the absolute value of 1 and 1/2 minus -3. Oh boy, we got negative numbers and positive numbers. We've got all kinds of stuff here, but we're not afraid because here we go. Absolute value of 1.5 minus a negative, which is a positive 3. It's going to be 4.5. Okay? Were you able to do those on your own? If so, great. If not, that's fine. That's fine. Go back, replay the examples, figure out what you did wrong. Okay? And then maybe see if you can find the length of zy. I don't know. Maybe you want to do that. Here we go. Congruent segments. We're going to use this word congruent to be able to describe things, to describe figures. Congruent means same size. I'd say equal, but otherwise we'd have to say equal. We're saying congruent. Because when we're talking about these, we've got two segments here. One is PQ, and the other is RS. Okay? Now, in my brain, I'm looking at them going, oh, they're the same length. But what if they were millimeters off? What if they were micrometers off? They wouldn't be congruent. So as they sit right now, I have PQ and RS that aren't necessarily anything. They're not related, except they're sitting right next to each other on this pink slide or purple slide, depending on what your computer monitor is showing. So how can we say something about them without knowing anything about them? Tick marks. I'm not talking about bugs here. I'm not talking about hiking. Okay? I'm talking about tick marks. Because what they're going to show us is they're going to show us that these two things are congruent by putting tick marks on them. Let me reiterate this for you. There's a tick mark. There's a tick mark. And because they both have one tick mark on them, they are both congruent. They're the same size. Okay? And so what we can say is three different things here. We can say that PQ is congruent to, hello, what's that little wavy thing? It's called a tilde. So from now on, for congruent, this is what we're going to use. I'm going to put it in quotes for you. Congruent is an equal sign with a tilde above it. So we can say that PQ is congruent to RS. Notice what I did here. I have to say that figures are congruent. I have to have these segment marks here in order to use the congruent. But if I talk about PQ, that's the length of PQ. That's its number value. It's 5 miles or 6 feet or whatever it is. Then I can say that the length of PQ is equal to the length of RS. Okay? So I either say that the figures themselves, which they have the little segments above them, are equal, or I say that the two measurements are equal. Or I could say PQ is congruent to RS. Okay? So that's what we're talking about. If we use the congruent symbol, we have to use the actual little figurine, that actual little segment over the top, or line, or whatever it is, okay? So here we go. That's how we talk about congruent segments. Now, another postulate. Remember, chapter 1, section 2, postulate number 2, segment addition postulate. If B is between A and C, indeed it is, then AB plus BC is equal to AC. So what we're saying is, if B is between, which it is, then this piece plus this piece is equal to this piece. Duh. Okay? The converse of that is true. I'm saying if I don't know where B is, so these are two separate things. If I didn't know where B was and someone told me, hey, AB plus BC is equal to AC, notice we have these two middle pieces that are the same, so it must be on the same little thing. Then B must be between A and C. We're going to work with this, but check it out. See how it works. The segment addition postulate basically says you take one piece of stuff, you put it next to another piece of stuff, and together they form the whole thing, however long it is. Okay, if you run 3 miles, and then you run 2 miles, you've run 5 miles total. Okay, this is not difficult. The wording can make it difficult. Don't make it difficult for yourself. Here we go. Use the segment addition postulate. B is between A and C. Sounds familiar. AC is 14 and BC is 11.4. Find AB. I get confused by words. I like to use pictures. Okay. Segment. B is between A and C. If you're having trouble with the concept of in between, talk to a friend. Between A and C. So AC, it's telling us, is 14. This is a good thing. They've given us the whole piece. Well, then they've said, if AC is 14 and BC is 11.4, what's left over? What's this? I'll put a question mark there because I don't know what it is. But look at logically what that means. If I was running a total of 14 miles and I'd already run 11.4, how many would I have left? Well, I'd say I've got the whole thing minus what I've already done gives me what? Anybody out there? 2.6. 2.6 miles left to go, home stretch. Okay? At the bottom here. S is between R and T. Find RT. Unfortunately, this time they have not given us anything in there. But they've given us a picture. This is good. Now, I know that the whole thing is 4x. But what's that equal to? It's equal to the two pieces being added together. So I'm saying that if I took RS and I added ST, I'd get the whole thing. The whole thing would be there. This is algebra. Notice what we've set up here. So I'm going to solve for x. Subtract 2x from both sides. So I'll have 2x. I'm going to combine like terms over here. Is equal to 35. Okay? Divide by 2. Divide by 2. X is equal to 17.5. But what are they asking me? They're not asking me to find x. They're asking me to find the length of the whole thing. Well, the whole thing is 4x. So 4 times 17.5. 2 times 17.5 is 35. 35 times 2. This is going to be 70. This is my answer. The whole thing is 70. So if you solved for x, you got half right. But we got to take that extra step, find out what the length of the whole thing is. Okay? The next slide is going to be one where you do these same two problems just about by yourself. I want you to pause. I want you to review this. I'd like for you to write it down. I want you to see if you can do it on your own. Then I'll do the problems. We'll check the work. Okay, here you go. All right, we're back. Here we go. We're going to check our answers. Kind of like the last example. Y between x and z. xz is 3. Whole thing is 3. xy is 1 1/3. So we're going to have 3 minus 1 1/3. So that'd be 2, and then minus 1/3, it would be 1 2/3 is equal to yz. Notice how that happens. Here we go. Same deal here. E is between D and F. Find DF. Well, I've got DF is 6x. And that's the sum of the two pieces. 3x minus 1 and 13. I'm adding 13 because when I put those two together, that means to add. Okay, so here we go. We're going to combine like terms. 3x plus 12 is equal to 6x. Subtract 3x from both sides. A little bit of algebra in my life. Love it. Okay, so x is going to be equal to 4. X is equal to 4. So what are we saying right now? If x is equal to 4, I want to find the length of the entire segment. Well, what's the entire segment? The entire segment is 6x. So it's going to be 6x is equal to 6 times 4, which is equal to 24. So the whole segment is 24. Notice what I'm saying here. 24. We don't know what the units are, but we've definitely got two parts here, finding x and then finding the length of the whole segment. These are good things. A couple more. Here's a real life example. If a car with a trailer measures 27 feet, car and a trailer measure 27 feet, the trailer is 14 feet, how long is the car? Well, if this is 14 feet and the whole thing's 27, you're thinking to yourself, it must be 13. The real question is, how do you know when you're supposed to get a new trailer? It's time. Okay? So this man needs to get a new trailer. Midpoint. The concept of midpoint. What are we talking about here? Mid. Middle. Okay? So what this is implying is I have 3 separate points through here. And if it's the midpoint, it's in the exact middle. Well, how am I going to show that it's in the exact middle? Well, if the 2 halves are equal, then we have the middle. So these tick marks tell me that the 2 halves are the same. We would say that B bisects AC. Okay? So if AC is equal to 6, then AB is equal to 3, and BC is equal to 3. Okay, so this is exactly what we're talking about right here. Bisect, like a bicycle with 2 wheels. It cuts it into 2 parts. 2 parts. Okay? These are good things. Now, aid stations. I'm not going to go through this problem. This is one I want you to try to do on your own and figure out on your own. Notice, here's me running up here, top of the hill at point X. Here's one of my water stations. Here's the first aid station, water station, first aid station, other water station. Use the information in this problem to try to figure it out. We're going to use this kind of like an opener tomorrow and kind of work collaboratively and see who came up with the best answer. Okay? This is a little extension thinking here. Love it. It's my kind of stuff. Working hard. Segment bisector. If it's a segment bisector, it's a ray, a segment, or a line that intersects a segment at its midpoint. It divides the segment at its midpoint into 2 equal parts. We know what this is. This is saying that we have a ray or a line or something that cuts it in the middle. And we're saying AB is cut in half. So these 2 halves will be the same. It's good things. All right? Notice, it doesn't look like it's in the middle. But since I marked it with these tick marks, it is in the middle. Even though it doesn't say it is, or it doesn't look like it is, it's saying, assume that those 2 things are the same size. Okay? Now, B is the midpoint of AC. Sorry, this should be XN. A is the midpoint of XN. Okay? A is the midpoint of XN. So what we're saying is, here we go, right here. Okay? So here's what's happening. We're saying that 5x is equal to 3x plus 4. Because what's happening is, if it's the midpoint, then the 2 halves are the same. So I'm going to solve for x. So x equals 2. So what are the halves? This half is 10 then. And this half is 6 plus 4. I just checked my answer because these two things should be the same, and they are. So the two halves are equal, okay? That was example 5. Here's example 5.5. Last slide. Try this one on your own. See what you come up with. We'll talk about it tomorrow if there are any questions. All right, thanks for watching, guys. We'll see you tomorrow.